Hello dear children, let us continue with the chapter Light, Reflection and Refraction. In the first module, we learned the reflection of light from a plane mirror and many other familiar concepts. We learned the laws of reflection. Hope you know to represent a plane mirror. A plane mirror has two surfaces, a reflecting surface where light falls and the other side is a coating. Children, plane mirror, we use it to see ourselves in it. It has its application not only in our homes, but also it is used in many other optical instruments. For example, a kaleidoscope. Kaleidoscope has three mirror strips kept at 60 degrees to each other, and it is used to see colorful patterns. Designers use it and get ideas from it. Plane mirrors are also used in periscopes. Periscopes are instruments that are used to see the objects which are not in the direct line of sight. We have learnt it. So plane mirrors have many applications. So in all these cases, light undergoes multiple reflection. So in this module, let us understand more about plane mirrors, especially the formation of image in plane mirrors and the characteristics of image formed by a plane mirror. In physics, object is anything which gives out light rays, either on its own or reflected by it. For example, a bulb, a candle, a tree, a pinhead of our face, etc. Objects can be of two types based on their size. Point objects, very small objects like that of a pinhead, and it is usually represented by a dot. And extended objects, they are represented by an arrow pointing upwards. So when we draw spherical mirrors, we'll be using extended objects. So always extended objects are represented by an arrow pointing upwards. Now what do we mean by a real object and virtual object? So A, as you can see, is a point object. And why is it a real object? Because light rays are emerging out of it. Virtual object doesn't exist. As an example, we can say an image that is formed in a plane mirror. It can be a virtual object if it is used to create another image in a second mirror. And the 3D objects that are created on the computers, they are all virtual objects. They don't really exist. Now let us look what is an image. Now what is an image? An image is an optical appearance produced when light rays coming from an object are reflected from a mirror or refracted through a lens. So children, when we look into a mirror, we see the image of our face in it, isn't it? So in this case, our face is the object and what we see in the mirror is the image. The image of our face appears to be situated behind the mirror. For example, while we watch a movie in a cinema hall, we see the images of actors and actresses on the cinema screen. We know that image is formed when is the image formed? When the light rays coming from an object meet, or they appear to meet at a point after reflection from a mirror or refraction through a lens. There are mainly two types of images, real images and virtual images. So let us take the case of a shaving mirror. What type of image does it produce? Or take the case of a plane mirror. What is the type of image produced by a plane mirror? So let us understand more about real images and virtual images. Children, let us analyze the four ray diagrams that is given here and understand some of the differences between real image and virtual image. The first diagram is that of a concave mirror. You can see an object that is kept upright or erect. Two light rays are emerging out of the object, and after reflection they are meeting at a point, and there we see the real image. You can see the real image that is inverted there. In the second, that is below that figure, you can see the second figure, that is a convex lens. You can see the object, and from the object three light rays, they are refracted through the lens and they meet at a point, and there we see the inverted real image. So in both the cases, we understood that real image is formed by the actual intersection of light rays either after reflection from the mirror or after refraction from the lens, and both the real images are always inverted. Now let us take the third figure. So there we have a convex mirror. There is an object that is kept erect, and from the object the light rays, two light rays go and they are reflected back. They don't meet, but how they look, how they are extrapolated or they are produced backward using dotted lines, and an image is, that is a virtual image, or erect virtual image is shown there. Actually, virtual image is an image that is not produced by the actual intersection of light rays. There is actually no image called as a virtual image, or that image doesn't exist. So a virtual image is represented here in dotted lines and it is erect. Now look, the fourth figure there, it is a concave lens. Here also we have an object that is erect, and the light rays, they also don't meet after refraction, but they are extrapolated, and there you can see a virtual image formed in front of the concave lens. So there we understand that virtual images are always erect images and they are not formed by the actual intersection of the light rays, either during reflection or refraction. Let us see the formation of image in a plane mirror. Let O be a point source of light. It reflects light in all directions, but we need only two light rays to locate the image. Let OA and OB be the two incident rays that are incidenting on the plane mirror MM', and let AX and BY be the reflected rays. See children, that reflected rays don't meet, so we extrapolate or produce them backwards so that they meet at I. So I is the image that is formed, and this image is a virtual image, since it is not since we know that it was not formed by the actual intersection of the light rays. And if this particular image that we see in the mirror can't be obtained on a screen, that's why we say that such type of images which cannot be obtained on a screen are called as virtual images. Here if you see very carefully, you can understand that the distance of the object to the mirror is equal to the distance of the image from the mirror. So that we will say when we just go through the characteristics. Hope you understood how to draw the ray diagram of the image formation in a plane mirror. Children, let us also go through the formation of image of an extended object in a plane mirror. Let AB be an extended object that is placed in front of the plane mirror MM'. Let two incident rays be plotted from the point A and B of the extended object, and let it be reflected through DE and GN, making an angle of reflection R1 and R2 with a normal. Let two perpendiculars be drawn from A and B to the mirror, and these light rays are reflected back along the same path. Now they are extrapolated backwards and we get the complete image A', B'. So children, what are the differences between the real image and a virtual image? Let us go through. Real images are formed by the actual intersection of light rays, whereas virtual images are formed when light rays coming from an object only appear to meet at a point when produced backwards. The image can be obtained on a screen, whereas the virtual images cannot be obtained on a screen. Real image is always inverted, whereas virtual image is always erect. Real images are formed by converging rays. Virtual images are formed by diverging rays, as we analyzed. Real images are formed in front of a mirror and it is formed behind in a lens. Virtual images are formed in front of a lens and it is formed behind in a mirror. Example of real image: concave mirror, convex lens give real images. Image formed in a cinema screen is also a real image. Example of a virtual image: plane mirrors, convex mirror and concave lens give virtual images. So children, from the previous slide we understood that the image that was obtained when an extended object was kept in front of a plane mirror was a virtual and an erect image, because the image was represented by an arrowhead that was pointing upward. That showed a erect image, and we drew that image by extrapolating the reflected rays backward and using dotted lines. So that was virtual. So we can conclude that in a plane mirror, the image that is formed by a plane mirror is always virtual and erect. The size of the image is always equal to the size of the object. When we look into a mirror, we look the same as we are. The image formed in a plane mirror is at the same distance behind the mirror as the object is in front of the mirror. Isn't it? Just check, look the diagram that is given below. Look the position of the object and the image and check the answer. Plane mirror shows lateral inversion, or the image is laterally inverted. What is the meaning of lateral inversion? You can see the figure here. You can see the person who is standing in front of a plane mirror. The right hand of the person or of the object appears to as the left hand of the image. So there the property where the left side of the object appears as the right side of the image and the right side of the object appears to be as the left side of the image is known as lateral inversion. So plane mirrors show lateral inversion property. So these are the main characteristics of image formed by a plane mirror. So hope you understood it. The answer to the homework questions. The first question, the diagram shows a ray of reflected light from a plane mirror. So you can see there 30 degrees is the angle that is made by the incident ray with the plane mirror. So, and you can find out that the angle of incidence there will be 60 degrees because altogether that angle represents a right angle. So, since the angle of incidence is 60, the angle of reflection will be also 60 degrees. So, the correct option is option B. Question 2. What happens when a ray of light falls normally or perpendicularly on the surface of a mirror? So, if a ray of light falls normally, that light ray will be reflected along the same path. Children, two ray diagrams, you have to copy it into the front side of your notebook. First one is the formation of image in a plane mirror by a point source of light in the fifth slide. And the formation of image by an extended object in a plane mirror, that is in the sixth slide, figure 2. So figure 1 and figure 2 as labeled in the fifth and the sixth slide, you have to copy it in the front side of your notebook very neatly. You have to draw it using pencil as I say, and the rays have to be directed using arrow marks, and hope you'll do it carefully and neatly. Thank you and stay safe.